Chapter 4, problem number 38. A Mercedes-Benz is parked on a road that rises 15 degrees above the horizontal. It also tells us that the mass of the Mercedes-Benz is 1,700 kilograms. They want to know the magnitudes of A, the normal force, and B, the static frictional force that the ground exerts on the tires. Okay, so we have an inclined plane, theta. We have the Mercedes. I'm just going to draw a box. The weight of the Mercedes acts straight down. We have a normal force acting perpendicular to the surface. That's going to have to be equal to the y part of the weight for equilibrium. And then the x part of the weight has to be equal to the force of static friction directed up the inclined plane. So the mass of the Mercedes is 1,700 kilograms. The angle is 15 degrees. And they want us to determine the magnitude of the normal force and the static frictional force. Well, the normal force is equal to the y part of the weight. So the normal force from Newton's second law, which states that the sum of the forces in the y must be equal to 0. So the normal force minus weight y is equal to 0, or the normal force is equal to weight y, where weight y is equal to the weight times the cosine of theta. Weight is m times g. So substituting, we have 1,700 kilograms times 10 meters per second squared times the cosine of 15 degrees. So the normal force is 16,421 newtons. Now, to find the force of static friction, we don't know the coefficient of static friction, so we cannot use the equation that the force of static friction max is equal to mu s times the normal force. And besides, we don't know whether the force of static friction is a maximum value, so we cannot use this equation. So what we have to do is use Newton's second law. The sum of the forces in the x are also equal to 0. So that means that force of static friction is equal to weight x, where weight x is weight times the sine of the angle, and weight is mg. So substituting, we have 1,700 kilograms times 10 meters per second squared times the sine of 15 degrees. And I'm getting 4,400 newtons.